Okay, we are back. This is Math 200. We're looking at Chapter 8 in the packet, specifically 8.5. And what are we working on here? Rationalizing the denominator. Rationalizing the denominator. So that means fixing the bottom of the fraction so that there's not a radical on it. There's no more square root on it, or cube root, or whatever they have on it. So look, this has a square root of 2 on the bottom. We don't want that. So what we're going to do is we're going to multiply top and bottom by the square root of 2. Well, what does that do for me? Well, on the top, it doesn't do anything. It makes it the square root of 6. So it doesn't change the top at all. But on the bottom, the square root of 2 times the square root of 2 is the square root of 4, which we now have basically turned into a perfect square. So the square root of 4 is just 2. And so voila, we have rationalized the denominator, meaning there's no more square root basically in the bottom. All right? Cube root is a little trickier because now think about this. We have 6 and we want the cube root of 9 is 3 times 3. Well, think about cube root, I need 3 of them in a row. So I'm not going to multiply this by itself like what we did there. I wouldn't want to take the cube root of 9 times the cube root of 9 and get the cube root of 81, because that's a perfect square, not a perfect cube. So what I have to do here, it's easier to see what you need if you break it into its little pieces. So 9 breaks down into 3 times 3, which means I'm missing one more 3. So I multiply this by the cube root of 3. I multiply this by the cube root of 3. On the top, I end up kind of messing up the top. It was a nice number. Now it's 6 cube roots of 3. And on the bottom, that is the cube root of 27, which is just 3. Oh, and now I can reduce it too, because 6 can be divided by 3, right? We can reduce this fraction, divide the bottom by 3, divide the top by 3. And so we end up with a final answer of 2 cube roots of 3 over 1, or just plain old 2 cube roots of 3. All right? So in this one, we've got the square root of 7x over the square root of 3y. Well, we want to fix the denominator. We're rationalizing the denominator. So we're going to multiply top and bottom. It's back to square root. So we're going to basically do that. The square root of 3y, the square root of 3y. On the top, I get the square root of 21xy. On the bottom, I get the square root of 9y squared. Well, that's now perfect. So the top stays the square root of 21xy. And the bottom becomes 3y. And we have rationalized the denominator. We fixed the bottom. So now, this is a little trickier because it's being added. So you can't just say, oh, I'll multiply it by the square root of 2, because I'd end up with 2 plus the square root of 6. So that won't do it. So this is what I was talking about before when we, on the last section, we multiplied something by its conjugate, and it turned out to just make it a regular number. That is what we're going to do. So the conjugate of the bottom is the square root of 2 minus the square root of 3. And we have to do the same to the top. So on the top, it's going to end up kind of messed up. But on the bottom, it's going to fix everything. So watch what happens. We do this, the square root of 6 minus the square root of 9 plus 2 square roots of 2 minus 2 square roots of 3. So what a mess that is. I can fix the square root of 9, but I can't add anything. There's 4 distinct terms on the top that I can't add. They're all in like terms. On the bottom, however, we get the square root of 4 minus the square root of 6 plus the square root of 6 minus the square root of 9. Well, these cancel. The square root of 4 is 2. The square root of 9 is 3. And there's a minus in between it. So now look at what happens. We get the square root of 6 minus 3 plus 2 square roots of 2 minus 2 square roots of 3, but it's all over. 2 minus 3 is negative 1. So basically, I'm going to divide everything by negative 1. And so I end up with negative square root of 6 plus 3 minus 2 square roots of 2 plus 2 square roots of 3. And that is my answer. It's all over 1. Now, often that won't work out to be a 1 or a negative 1 like this did, and you'll end up with like over 5 or something like that. But this one worked out where we just had to distribute a negative throughout. Okay, so this, we're back to the start. That's just like this problem, the square root of 12 over the square root of 7. Oh, it's a little different because the square root of 12 we can fix a little bit, right? So the square root of 12 is the square root of 4 times the square root of 3, 2 square roots of 3. So we got 2 square roots of 3 over the square root of 7. So we, simplest radical form, the top, the numerator. And now we still have to rationalize the denominator. So we're going to multiply top and bottom by the square root of 7. And so on the top, we get 2 square roots of 21. On the bottom, we get the square root of 49, which is just 7. So lots of students skip that whole square root of 49 part because they know the square root of 7 times the square root of 7 is just 7. All right? Lovely. So just, what? Oh, just 2 more problems. I need 5. 6 next. So we've got the cube root of 9y over 7. And, oh, wait. This one, rationalize. Oh, wait a second. I think I'm going to have to redo that last one. Because I think they want me to rationalize the numerator, which is kind of odd. Normally we focus on the denominator, but I guess, okay, here, sorry. We'll rationalize the numerator. So I got to redo number 1 then. Number 1 was the square root of 12 over 7, but they wanted me to fix the top, not the bottom. So we don't care about the bottom this time. We do care about the top. Remember, that was 4, the square root of 12 was the square root of 4 times the square root of 3. So that's 2 square roots of 3 over the square root of 7. And now we got to fix the square root of 3 part. So we're going to multiply top and bottom by the square root of 3. So now we get 2 times the square root of 9 over the square root of 21. And 2 times 3 over the square root of 21. And that is 6 over the square root of 21. There we go. Sorry. I didn't read the instructions carefully. I rationalized the denominator on that one instead of the numerator. Now, I have seen rationalize the numerator, but it's all the way into calculus when you're in calc once in a while. You'll want to either rationalize the numerator or rationalize the denominator, depending on what, oh, I don't want to explain calculus, but there's when you're doing integrations. Okay, so this one we're going to fix again the numerator. We're rationalizing the numerator, not the denominator. So it is the cube root of 9y over the cube root of 7. And we don't really care about the bottom now. We're just trying to fix the top so there's not anything in there. So let's think about what that is. That is the cube root of 3 times y over the cube root of 7. Okay, and so we're just trying to fix the top. So I need groups of 3 to get out of there. So that is going to be, I'm missing a 3. Now I have 3 3s, and I'm missing 2 y's. And so I got to do the same thing to the bottom, the cube root of 3y. And so here we are on the top now in the numerator. we have the cube root of 27y cubed, and on the bottom, we've got the cube root of 21y squared. So now the bottom is going to be Jones. That's not going to be fixed. But this top is 3y. The bottom is still the cube root of 21y squared. All right. And then one last one, which is, again, we're going to rationalize the numerator, not the denominator. So when they give you the square root of x plus the square root of y over the square root of x minus the square root of y, we're just trying to fix the top, the numerator. And so that is going to be, because it's being added or subtracted, we're going to multiply by the conjugate, the square root of x minus the square root of y. We'll fix it. The square root of x minus the square root of y. So on the bottom, that's not going to fix anything. On the bottom, it's going to be, I think, a trinomial. Let's see how it plays out. We get on the top, we get the square root of x squared minus the square root of xy plus the square root of xy minus the square root of y squared. On the bottom, we get the square root of x squared minus the square root of xy minus, again, the square root of xy plus y squared, the square root of y squared. All right, so now let's fix all of these. Combine the like terms on the top, that goes away. Combine the like terms on the bottom, it's -1 square roots of xy minus 1 square roots of xy, that's -2 square roots of xy. This is x, this is minus y. This is x, this is plus y. So now here we have our answer. On the top, we have x minus y. On the bottom, we have x minus 2 square roots of xy plus y. And that is, we've rationalized the numerator. All right. Next one we'll do is 8.6.